So here we'll turn to the second economic model in this chapter, which is called the Production Possibilities Frontier, or PPF in short. As the name suggests, this is talking about production in an economy, and it's talking about what is possible when we think about production. Okay, and we'll talk about what we mean by frontier a little bit later. But this is again a simplistic version of reality where we are thinking about the complex world where or the real world where thousands and thousands of goods and services are produced, but in this type of an economic model we can really try to explain that complex phenomena by just thinking about or just making an assumption where we think about an economy only producing two goods. Okay, so the production possibilities frontier is really, when we talk about what is it, it's really just a graph, a simple XY graph that shows the combinations, the various combinations of output that an economy can possibly produce. The word possible is important here, possibly produce, given the available factors of production. You know by now what factors of production are: land, labor, capital, or entrepreneurship that are required in the production process. So given the available factors of production and technology. Okay, so these are our resources, and we're thinking about what are the various combinations of the two goods in a simplistic world that we can produce as an economy given these resources. Okay, so in this type of a model, we're going to make two basic assumptions, which is to say that we are going to consider an economy where we are producing only two goods. And just for our example, we are going to take the example of iPads. Very important to me. I'm teaching on an iPad right now. And masks. Again, very important right now. Okay, so we'll just take these two goods that we're producing, and we are going to make an assumption of the resources that are available to us for production. So we're going to just say that we're using one resource, which is labor, which is measured in the number of hours that you put into work. And we are also going to think about, well, how many hours are there? So total hours available to us in a month. If we are thinking about monthly production, we are going to say, well, we have 50,000 hours available to us. Okay, this can be any number for the purposes of your exam or your homeworks, but really right now for the example, we are going to roll with this. Okay, so 50,000 hours are available for production. Okay, so let's turn to what other information do we need in order to think about the production possibilities frontier. So like I said, we are producing iPads, and this is going to be calculated as the number of iPads we can produce, or masks, which is going to be in the number of boxes of masks we can produce. Okay, so number of boxes right here. The other information that might be given to us is to say that, well, how many hours does each product require in its production? So for one iPad, we are given that this requires 100 hours, and this is going to be more than the hours we require to produce one box of masks, because iPads are more complex and require or would require more number of hours. Okay, so let's roll with this right now with these numbers, and remember we have 50,000 hours. Now, if you have, it's good to stay, have a paper and a pencil ready, and also a calculator ready when we work through these examples for chapter 2 and also for chapter 3, when we will talk about production possibilities frontier. Okay, so let's think about what this table is and why do we need to make a table like this. Let me erase this so we can explain what's going on. Okay, so what we'll do is we'll make a table like this, in which the first column right here is going to represent points on the graph. Okay, so these are going to be points on the graph. The next two columns right here are going to tell us how are we allocating those 50,000 hours between iPad and mask production. Okay, so how are we employing or allocating those labor hours? Okay, how are we splitting that 50,000 hours? Okay, and the last two columns, which are right here, the last two columns right here represent what do we actually produce in terms of number of iPads and number of boxes of masks given those hours. Okay, so we have all the information that we need on this slide, and let's start with a simple example which says that let's consider putting all of our hours towards iPad production. Okay, so remember, if you're putting all of these hours towards iPad production, we have nothing left for mask production. Okay, so remember these two columns, in a particular row, these two columns should add up to 50,000 always. So this plus this will always be 50,000. Okay, so if we're putting 0 towards mask production, we are not going to be producing any masks then, right? So we don't get any masks. This is again signifying or representing production. And then if we want to figure out how many masks can we produce, we can go back to, let me do the math over here. So for one iPad, we require 100 hours, right? And so we want to find out how many iPads can we produce given 50,000 hours. Okay, the best way to do this is to assume that what we want to calculate is X. Okay, so let's say this is X. You cross multiply and you get X equals 50,000 hours divided by 100 hours per iPad. Okay, so we get X, which is 500. Okay, 50,000 divided by 100 is 500. So 500 iPads can be produced using 50,000 labor hours. Okay, next we are going to consider different possibilities. Okay, so let's assume we have 40,000 hours devoted to iPad production. What you want to do is calculate these different blanks, and as far as point C is concerned, if I'm telling you that we are producing 250 iPads, you should be able to compute these 3 question marks. And similarly, you want to fill up this row, and finally, because we like zeros, here is another row that you want to compute. Okay, so this is a good time to pause the video and work through this before you see me solve it. Okay, this is important that you stop here and do this on your own, because this is going to follow through. These concepts are going to follow through until chapter 3, where we will not just consider one economy but more economies. Okay, so this is what we had, and we wanted to calculate. I'm assuming you have done your work by now, but let's try to fill in the blanks. Okay, so let's look at point B. Okay, we're focusing on this row only. So if we were given that 40,000 hours went towards iPad production, and we know that we have a total of 50,000 hours, then these two columns, right, this plus this equals 50,000, right? So we're left with 10,000 hours which go towards mass production. Okay, so in similar ways you would calculate how many iPads you have with 40,000 hours, which is going to be 400. Essentially, to get 400, you're dividing 40,000 by 100. And for the number of masks, we know that one mask takes 10 hours, right? And if we want to calculate how many masks, let's say this is Y, how many masks can we produce with 10,000 hours, you're again going to cross multiply, and you're going to get Y equals 10,000 divided by 10, which is equal to 1,000. Okay, so we're going to put the number 1,000 here. Okay, and then we are given in row C, we know that we are producing 250 iPads. Okay, and we have to fill up the rest of the blanks. So if one iPad uses 100 hours, then 250 iPads would use 100 times. I mean, you can do this many ways, but let's say you wanted to calculate X hours, right? Again, you cross multiply and you would get X equals 250 times 100 hours, which is 25,000 hours. Okay, so at this point we can write down 25,000 hours must have gone into iPad production to produce 250 iPads. Okay, so in similar ways, once you have this number, you're essentially doing backward engineering, and we know that these two columns should add up to 50,000. Okay, so we are going to write down 25,000 here, and with 25,000 hours going into mass production, we are going to be producing 2,500 masks. Okay, and in similar ways, you're going to fill out these last two columns, or sorry, the last two rows, where if we were producing 4,000 masks, that would require 40,000 hours. And then we are left with 10,000 hours for iPad production, which leads us to produce 100 hours. Okay, and finally, if we were producing 0 iPads, we must have put in 0 hours towards iPad production, and all of the hours must have gone into mass production. We wish 50,000 divided by 1,000, which would give you, 50,000 divided by 10, which would give you 5,000. Okay, so now what we're going to do next is take these 3 columns, okay, and try to make a production possibilities frontier. So we're going to plot all of these points on a graph. So I've taken those points, the first column which represents points on the graph, and the last 2 columns that represent production. Okay, so let's try to make a graph here. Okay, the graph is going to require us to know what's on the x-axis and what's on the y-axis. So let's assume iPads is x and masks are y, right? So This is iPads, and these are masks. And now we are going to plot these points. So you're going to read a point like A as X comma Y, or A can also be written as 500 comma 0, okay, which is your x-intercept, right? The x-intercept has y equals 0, so let's draw this with a different color. But first let's draw the scale so it's easy for us to see where we are at. Now I'm counting iPads on the number of iPads on the x-axis, so I'm going to draw a scale that is commensurate with the numbers we've got. Okay, and similarly, because mask production, or in terms of number of boxes, is in thousands, so it's easier to draw a scale in thousands. Okay, so let's draw point A, which is 500, which is somewhere here. Let's mark this. Then point B is right here, 400 comma 1000. So this is going to be this point right here, where X is 400, right? This is 400 and this is 1000. Okay, so this is point B. C is 250, 2500. So this is going to be some point here, somewhere here, point C. And D is going to be 100, 4000, which is somewhere here. And finally, E is our y-intercept, which is 0, 5000. Okay, so what we want to do now is join these 5 points. Not bad. Okay, so point B is actually here, D is here. Okay, we've joined these points, and this red line that we see is called the production possibilities frontier. Whoa, we've done it. Okay, so what is important to know is that if we are on that red line, so there are obviously infinitely many points on that red line, but right now we've only marked up 5. Those are points that are efficient because we are utilizing all of the 50,000 labor hours that were available to us. Okay, now what I would like you to do, since you've drawn this, you can try to mark 2 other points. Okay, one point would be, let me mark this with a different color. So let's draw point F. I would like you to mark this on the graph, which is 100, 3000, right? So 100 iPads, 3000 masks. And let's mark this with a different color. A point like G, which is 300 iPads and 3500 masks. And I want you to pause the video right now and make these points. So let's draw point F for now, which is 100 iPads and 3000 masks. Okay, so a point like F is somewhere here inside this triangle, okay, or below the frontier. The frontier is this line right here. This is the production possibilities frontier. Okay. But if we are operating at a point like F, we know that we are not utilizing all of the 50,000 labor hours. Of course, any point in this triangle that you see, anywhere here, is possible because it's going to utilize less number of hours than 50,000, but it is not going to be efficient. Okay, but a point like G, which is, let's use another color here, a point like G is 300, 3,500. So 300 and 3,500 would be somewhere here. Yeah. And so a point like G is above the production possibilities frontier. This is above the PPF. And this is going to require many more hours than we have for production. Okay, so many more hours than 50,000. So let's try to write this down. So a point like F is below or under the PPF. And a point like G is above the PPF. Okay, so let's try to summarize what do we know now about what are its different concepts that the production possibilities frontier is useful in explaining. Any point that lies on the PPF, which are points like A through E, are efficient and possible. Okay, which tell us that any points like A through E represent the fact that resources are being utilized fully. The points that lie below the PPF or under the PPF, like point F, are possible, but these points are inefficient. These could indicate that resources are underutilized. Like workers are unemployed, or factories are lying idle, etc. Okay, and any point that is above the PPF is impossible or infeasible. And we'll talk a little bit about how we can get to that point with economic growth or with international trade. So chapter 3 is completely devoted to studying international trade and how we get to a point like G, which is above the production possibilities frontier, where we are able to produce more of both goods like iPads and masks.